So how do vaccines kill the virus? Vaccines work by triggering antibody production in our bodies without actually giving us the illness. Different vaccines have different mechanisms of doing this, but they all produce antibodies and memory cells for long-lasting immunity. Let's look at the types of vaccines. Live vaccines contain a weakened form of the pathogen. These offer the most protection because it most closely resembles an actual infection with the virus. Inactivated vaccines contain an inactive form of the pathogen. These are safer than live vaccines because they can't get you sick, however, they are less effective. Subunit vaccines contain a part of the pathogen. These can be difficult to develop because scientists need to find a part of the pathogen that will elicit a good immune response. Toxoid vaccines contain inactivated toxins that have been released by different bacteria. These are then injected to elicit an immune response. Conjugate vaccines contain a combination of two antigens. This is used when the disease-specific antigen is not strong enough to be used alone, so the combination creates a stronger response. Now on to the newer vaccines. mRNA vaccines contain the instructions of how to make the antigen. This means they tell your body to make the antigen that triggers the immune response. Viral vector vaccines work in a similar way, where they carry the DNA coding for the antigen, and then your body makes the antigen and elicits the immune response. We've been using these new technologies to fight COVID-19. Pfizer and Moderna are mRNA vaccines, and AstraZeneca is a viral vector vaccine. mRNA and viral vector vaccines give the cells a recipe to follow. The final outcome of the recipe is the creation of the antigen. Once the antigen is made, antibodies are created by B cells. These attach to the antigen and trigger the destruction of those. All three vaccines create the spike protein. The spike protein is a classic spike seen on the COVID-19 virus. This is why our three vaccines have been deemed interchangeable. They have the same mechanism. This is also part of the reason these were developed so quickly. The spike protein was already heavily researched, so scientists were able to identify this as a target quickly. The other reason is because, unlike traditional vaccines, scientists don't need to grow the virus. Once the DNA sequence of COVID-19 was uploaded, researchers were able to start working immediately. That's great, but how does that protect me? Great question. When B cells come into contact with the virus next time, they rapidly produce antibodies that flag the virus so that your cells know to kill it. The end result is less severe symptoms of the disease or immunity to the disease due to quick elimination from the body. But I'm healthy, why do I need to get the vaccine? It's important for healthy people to be vaccinated because while they might not get as sick, they could still be a carrier. This means they could infect someone else with the disease who might be at a greater risk of becoming very ill. By getting vaccinated, you are protecting yourself and others from getting sick. This leads to something called herd immunity.